All right, everyone, welcome to the Hazardous Waste Toxicity class, California versus Federal. But now let's let me introduce Steve Koester from Oxnard Department of Fire and Rescue to be the presenter for this class.
All right, thank you. Thank you. All right, so I started this class I think about 6 years ago. And I did it because I asked some of my regulatory buddies questions about toxicity, and none of them knew the answers. So I thought, oh, there's a need for this. So I kind of created this class, and I figured I would come to the conference and teach it, and everybody would learn it, and then attendance would drop off, and there would no longer be a need for this, and I would just go away. Well, this is the largest attendance for a class that I've had in the history of teaching this class, so apparently it's not going away. Now, I don't know if I'm going to go away or not. I retired in 2012. I don't get paid to do these things, so why am I here? Sometimes I don't know why. But I think it is important for you guys to have this information. I'm still available to do this, so here I am this year. Will I be here next year? I don't know. Maybe, maybe not. I might hand the baton off to somebody else. For me, I like to make training fun. I realize haz waste is boring. I know what I'm dealing with, and it's not exciting. I do everything I can to make it exciting. Don't be offended by some of my bad jokes. We're also going to do an exercise for this class, and it gets more difficult as this class gets bigger. I had 100 copies, and I went to registration. They said, oh, Steve, you have more than 200 people signed up for your class. And I said, oh, interesting. So they made copies for me. I think it's really important to do the exercise because it's hands-on. You guys are going to do some real waste determination. So I'm going to talk about this stuff, and then you guys are actually going to do it. I don't care if you talk amongst yourself. This is not a test, but I want you guys to understand this. I know a lot of times some of these classes, you know, the instructor's up here and he's monotone and he just stands here and you know, it's like they don't really care, and are they really conveying a message? Well, I want you guys to understand this. That's my goal as an instructor, is for you guys to know this. And so we're actually going to do it. And how many people here are from industry? So this is a great class for industry, because if you guys can't make a good waste determination, then you're going to be in trouble, right? And then the rest of you, I'm assuming, are inspectors. And if you're from a government agency, if you don't understand this, how can you audit the business? So very good class for both industry and for government. All right, so a little bit about my background. 25 years with Santa Fe Springs Fire Department. I'm currently doing a brief stint at Oxnard Fire Department. I'll be there till the end of the month, and then what I'm doing after that, I don't know. So that's my old desk where I'd make magic happen. And then you can see me, see if I can get used to laser point. I have a really cool laser, and the on-off button has gone rogue on me, and it won't go off. So I don't want to put somebody's eye out with it. So I have to use this weak red one. But this is me out in the field doing inspections. All right, when EPA was deciding that they wanted to regulate hazardous waste, they said, what are we going to regulate? And in their minds, they came up with 4 categories that would make something a hazardous waste. 4 different categories. Everything that is a hazardous waste must fit in one of these 4 categories. It's a really good idea to have these categories memorized and then know what the definitions are. So what do we got here? Something's burning, right? And they don't call it flammable because EPA's initial definition was different than DOT's definition of a flammable material, so they called it ignitable. But interestingly enough, DOT kind of modified theirs, and now they're the same definition. So what is it? It is a liquid with a flash point less than 140 degrees Fahrenheit and not an aqueous solution of less than 24% alcohol. They were trying not to regulate like wine and beer and things like that. Now, if I was a whiskey manufacturer and I made a batch of whiskey that tasted like crap and I couldn't sell it, then it would not be exempt from being a hazardous waste because it would be greater than 24%. So what proof would 24% be? All you drinkers. Come on, you guys, speak up. 48%, right. So what is whiskey usually? It's usually 80 proof, so that's going to be way more concentrated than what is exempt out of ignitability. A solid capable of causing fire through friction, absorption of moisture, or spontaneous chemical changes, and, this is an and, so it has to do this as well, burn vigorously to create a hazard. Example would be magnesium shavings. If I light magnesium shavings on fire, I get a very intense fire, right? Can I look at it? I can't even look at it because it's so bright. What happens if I put water on a magnesium fire? Will it go out? Why won't it go out? It burns so hot that it changes water to oxygen and hydrogen. So it's like throwing fuel on the fire. So that's a hazard. And EPA said materials that meet that hazard are ignitable. Now what if I had absorbent saturated, but not overly saturated, but this saturated with gasoline? Do you think that meets the definition of ignitable as a solid? Come on, yes, no. Nobody's non-committal. You think it does? People think it does meet that definition? All right, is it capable of causing fire through friction, absorption of moisture, or spontaneous chemical changes? So like, it's possible, but probably not likely. If it did burn, if it was saturated enough, it would create a hazard. But it'd have to ignite through a spark or something like that. And then ignitable gases, as defined by DOT, 49 CFR 173.300, so that takes us to DOT definition. And then an oxidizer. What an oxidizer does is it can change a normal material and make it more ignitable. If I took like a piece of cotton and I light it, it's going to burn, but it's not going to burn so vigorously to create a hazard. If I saturated that with liquid oxygen, then it would burn like it was gunpowder. I mean, it would just flash up instantly. And that's why they regulate oxidizers under ignitability, because they won't burn themselves. And what do we got here? All right, so when we think of corrosivity, we typically think of pH, but remember, one of the definitions on it is something that will corrode steel. So it's got to be a strong alkaline or a strong acid to be considered to be corrosive. It's got to have a pH of less than or equal to 2 or greater than or equal to 12.5. What's Coca-Cola? pH of Coca-Cola? No, it's an acid. So it's about 2.3, 2.4. So there's a lot of materials that are weak acids that we commonly use. Something that has a pH of 2 or less is a pretty strong acid. And then 12.5, that's a pretty strong alkaline. Soaps, even stuff like ammonium hydroxide, pH of 10, pH of 11, they're not going to be corrosive. So EPA doesn't, it's not everything that is an acid or everything that's caustic or a base. It's the far extreme. What don't we see on here? Solids are not covered by EPA, but California does include solids. And what do we got here? Reactivity. Reactivity is a reaction, a reactive material. If a material reacts faster than the speed of sound, that is an explosion. What movie is this from? Butch Cassidy and the Sundance Kid. They used too much dynamite to get the safe open. So that is a good example of reactive material. This one's kind of more longer than some of the other definitions we looked at. Normally unstable and violent change without detonation. That could be a material that reacts and expands a lot. Reacts violently with water, so water reactives. Forms explosive mixture with water, things like metallic sodium. Mixed with water forms toxic gases, and then the one underneath is cyanide or sulfide-bearing waste that can generate toxic gases when mixed with non-corrosive liquids. So if it's mixed with normal liquids and it gives off corrosive or the toxic gases, it's considered reactivity. So reactivity is things that react and cause damage through physical damage or through some type of toxicity. And then capable of detonating under strong initiating agent, explosives, and forbidden explosives. The only one that's not covered would be Class C explosives, and those are like safe and sane fireworks. If you do something crazy with them, you can get them to blow up, but under normal circumstances, they will not blow up. Anybody ever alter a Piccolo Pete? All right, so if you were to do that to an extreme, maybe you could get them to blow up, but typically they will not. And it takes us to toxicity, right? Skull and crossbone. However, there are two types of toxicity. So what are we looking at? What type is this? They're all dead. So it is acute. It affects them immediately. This is not acute, this is chronic. You know, it's caused some kind of effect over time. Which one do you think the EPA was interested in? Acute, right? Federal characteristic is based on chronic toxicity. When they were thinking about toxicity, they didn't care about acute toxicity. They only cared about chronic toxicity. Why do you think that is? Why would they do this? There's got to be a reason behind this, right? What EPA was thinking is if I have this thing, whatever, and I have it as a waste, where's it going to go? It's going to go to a landfill. And landfills could leach into groundwater. And if they leach into groundwater, it could affect our drinking water. And so we could have long-term health effects from drinking water. So that's why they based it on the safe drinking water standards. When they were thinking about this 1976 is when Rcra was written. So in the 70s, what they were concerned with was chronic toxicity in groundwater. They figured if it goes to a landfill, it could leach to groundwater. We drink that water, what kind of health effects? What they did is they took those standards, which EPA had a lot of good data on toxicity of those materials, and they multiplied it by 100. So at whatever the safe drinking water level was, they took that and they figured there'd be 100-to-1 dilution by the time you drank it. So if you put it in the landfill, it leaches to the groundwater. When it gets to the groundwater, it's going to dilute 100-to-1, and then you're going to drink it. So that's how they came up with the levels. I mean, it's a swag, right? Scientific, wild-ass guess. They had to pick a number, right? Why is it 100? Why is it not 1,000? That's the number that they came up with. In the 1990s, there were amendments to the Solid Waste Act, and they added 26 additional materials. So initially, there was only 14 materials that the EPA considered to be toxic. 14 materials that were considered toxic by the EPA. Does that seem low? I'll start doing Gordon Graham. He's very addictive, isn't he? Okay, so in the 90s, they added 26 organic compounds. All the initial ones, 8 metals, 4 pesticides, 2 herbicides, but no real solvents. And they started to look at some of the data that they had on toxicity for some other materials. Initially, it was supposed to go all the way up to D55, but after comments, some of the materials got cut off, and they ended up with only 26 materials that got added. So D004 through D043 are the waste codes. Not a lot of materials, right? How many is that? That's 40 materials. So that's all that EPA considers toxic, 40 materials. Does that sound good? It's pretty low, huh? So Rcra toxicity determination. How do I determine if my waste is a characteristic waste for toxicity? Liquids can be tested using any method as long as it is documented quality control. So it's up to the lab to determine how they want to test that material to determine if it's toxic, if it meets the table that EPA came up with. So when we talk about this, a lot of times we use acronyms, but if you're testing for toxicity, there's no one test. It depends on the substrate that's being tested. However, if we look at the next line, it says, by definition, liquids contain less than 0.5% solids. So it's less than 1% solid. So think about a waste material. How often does waste, is it a pure liquid? I mean, I'm sure there are cases, there are waste that is pure liquid, but what the EPA was concerned about is that the toxins might be contained within the solids, and they wanted to make sure if you were going to address that solid portion. So solids have to go through a procedure that mimics landfill conditions called a toxic characteristic leaching procedure. Originally, EPA had a test. It was an EP test, and they could not duplicate the results of that test. In other words, if they took the same waste and they went to different labs, they got different results. And they got a lot of complaints from industry saying that you could determine toxicity based on which lab you went to. If you went to a good lab, it wouldn't be toxic. If you went to the wrong lab, it would be. So they redid their lab procedure in the 90s and came up with the toxic characteristic leaching procedure. So solid liquid samples are separated. So you separate the two. The solids are processed and then combined with the liquid portion for analysis. There's a lot of fudge factor in that, because if you think about taking the liquids from the solids, and then you do something to the solids, you dilute it, you create a liquid, and then you mix the two liquids together. I don't know how they figure out the percentages to make a proper determination, but I bet there's some lab magic going on in there somewhere. They use acetic acid for a leaching agent. They add 20 parts acid to 1 part sample. It's a key thing because there's a 21 to 1 dilution. So if you start with a material that's right at the threshold of what would make it hazardous and you dilute it by 20, it's impossible for it to fail. So sometimes if you know the concentration, you don't have to run the T-clip because it would be impossible for it to fail. And we'll get into that more when we talk about California. They put it into a tumbler for 18 hours. So it's in an acid and it's kind of going around. This is the digesting process that basically mimics what happens in a landfill. If you put material in a landfill, it's like a big digester. There's all kinds of bacteria in there, and they're eating away at everything. And as they eat away at stuff, they give off an acid, a byproduct. So it becomes kind of a weak acid environment in a landfill. And they want to make sure that your waste doesn't leach out in a landfill. If it doesn't, then they're not worried about it migrating to a water table. But if it does, they don't want it in the landfill. So that was EPA's idea on toxicity, trying to keep stuff that would contaminate groundwater out of the landfill. Not necessarily keeping toxic materials out of the landfill, just stuff that would leach. The test results are compared to numbers listed in Table 1 of the California Code of Regulations. Of course, it's in federal regs, but since we're in California, I'm giving you all the California sites to get the information from. So if it's equal to or greater than the number listed in Table 1, then it's going to be a Rcra hazardous waste for the characteristic of toxicity. Equal to or greater, well, that's what I said. Federally regulated metals. The reason I focus on the metals is because this is what commonly is encountered by businesses. Arsenic, barium, cadmium, chromium, lead, mercury, selenium, and silver. Mercury is kind of a unique metal, right? It's the only metal that is a liquid at standard temperature and pressure. So if you want to test for mercury, it's a separate test than what the other metals are tested by. So now, I mean, that was the feds. We're done. Pretty easy, huh? 40 materials. You run a test. If it's on a table, if it's greater than or equal to, it's a Rcra hazardous waste for toxicity. But do you think California liked that? No way. This is Jerry Brown's glamour shot. You guys like it? He went down to the mall and said, he went to those glamour shots and said, hey, I brought my flag with me. All right. This is how many people downloaded the presentation? God bless you. How many people have it on their mobile device? And God bless you. So this is really good reference material. If you don't have it with you, I recommend that you download this. You're not going to remember all this stuff, right? My job is to kind of explain this stuff to you, and then you guys use this as a reference. Well, here's California in a nutshell. California regulates 20 metals and inorganics. EPA was 8, so that's quite a bit more, isn't it? 18 persistent bioaccumulative toxic substances. We have an oral LD50, a dermal LD50, an inhalation LC50. We've got a fish bioassay, we've got carcinogens, and we got a ridiculous requirement that nobody can understand. And if you think I'm making that up, we'll take a look at it, and you guys will agree with me. California's version of toxic constituents. Table 2 of 66261.24a for metals and inorganics, and then there's Table 3 for bioaccumulative and persistent organics. And both tables have liquid thresholds and solid thresholds. Remember, the EPA was only concerned if the material would leach in a landfill. California is concerned if the concentration is high enough, they don't even want to go to a landfill. Because they're concerned on the test may not be that good, and if the test is wrong and it does leach, it is going to impact the water table. So California says, we don't want high concentrations of nasty stuff in the landfill, regardless if they leach or not. So that's what a total threshold limit concentration is. And then California has a soluble threshold limit concentration that is very similar to the feds, but it is not the same. So replaces the T-clip with the TTLC and the STLC. The TTLC is total threshold limit concentration. Doesn't take into account any dilution. It's going to tell you the concentration of the contaminants that you have in your waste. Total concentration. There's no sample dilution and doesn't consider landfill conditions. Then we have an STLC, soluble threshold limit concentration, which is the WET test, waste extraction test. Same concept as the T-clip, but uses a different acid and digests for a greater length of time. Basically, California did not like the federal test. They didn't like the criteria of the leaching process. They wanted something more robust. So if I have a waste and I test it using the federal criteria and it passes as non-hazardous waste, does that automatically mean it is going to pass a California test? And that's the big thing. California's is much more robust. State wet procedure from 22 CCR, used for 17 metals, 2 inorganics, asbestos, 10 pesticides, and 8 other organics. Solids are milled to 0.45 microns. It's diluted 10 to 1. That's a big difference because the other one is 20 to 1. So it's half the dilution. That alone could make it fail, just the dilution factor. Leaching period is 48 hours. That is 30 hours longer in an acid solution than the feds have. 30 hours. It's more than double. Remember, theirs was 18. This is 48. And then the leachate would be analyzed. And the sodium citrate solution is a slightly stronger acid than the acetic acid. So it's a little bit stronger acid, and it's got a much longer time with less dilution. So the state-only metals are bold: antimony, beryllium, cobalt, copper, molybdenum, nickel, thallium, vanadium, and zinc. Some of these metals are pretty common, right? Like copper, nickel. Do we see that in industry? Do we see that in alloys? If I have a brass alloy, does it have copper in it? If I have stainless steel alloy, does it have nickel in it? Yes. How about Things that are galvanized. What are they galvanized with? Zinc. So there's a lot of materials in industry that have these metals that are not given to you with a material safety data sheet. So it's kind of confusing if you start out with something that's not even a hazardous material, and then I generate a hazardous waste, and there's no chemical change. How did that happen? Do you think that gets caught sometimes, not being managed properly? I went to a facility and did an inspection. They were polishing bumpers, and I went to the trash, and I took a sample of the buffing waste that was in the trash, and the concentration for chrome was 180,000 ppm. 180,000 ppm. What's the threshold for chrome on the federal level? Let's see if there's any geeks in here that have it memorized. I do. 5 milligrams per liter. Because remember, we only care about if it dissolves. Do you think 180,000 parts per million might dissolve 5 milligrams per liter? And that was in the trash. So, it gets overlooked all the time. And that's part of the reason to spend so much time on the metals, because that's where I saw the most problems. All right. The feds do not differentiate on chromium. It just says chromium. California differentiates hexavalent from trivalent chromium. How do you know which one it is? It's kind of hard to know, huh? So sometimes you just have to go with the lower standard. California has an STL limit for chrome 3, only if the waste passes the T-clip process. So if it's not federally regulated, they have a chrome 3 test. Asbestos. Asbestos is, what is it? What is asbestos? It's a mineral. It's not a chemical, it's a mineral, right? And it's found naturally. So when they do analysis for asbestos, there's no STLC. It's not going to leach out. Basically, you're only using a totals test, and they're looking through a microscope and counting the number of crystals within a square area or a circular area. So it's concentration based on area. So it's kind of unique. Only applies to substances that are friable. What do I mean by friable? It can get in the air, has the ability to get in the air. If I have it fixed in a tile, so it's part of the material in a flooring, is that a friable material? No. If I take a sander to it and I sand it, I've created a friable material. But sometimes asbestos is not friable. What they're looking at for hazardous waste is friable asbestos. And there's 6 different minerals that are in the asbestos family. Barium excludes barite. Barite is a mineral. It excludes barium sulfate from the TTLC column. So there's a couple exclusions there for a few of the metals. All right, scrap metal exemption. This is where it's found in Title 22. Rethinking that. This is very common in industry to generate scrap metal. Both the federal government and the state government allow for recycled scrap metal to be excluded from hazardous waste requirements. All you have to do is recycle it and it's excluded. So if you send it off to be reclaimed, it will be excluded from being a waste, which it excludes it from being a hazardous waste. So you don't have to meet any waste requirements. The feds are pretty broad on their definition of what is scrap metal. The state is a lot more restrictive than the federal government, which makes sense, right? State is more conservative on almost everything. These are excluded from being excluded. Does that make sense? These are not scrap metal. Scrap metal gets an exclusion, but they don't want these to be included in the exclusion. So they're excluded from the exclusion. Lead acid batteries, they have other materials in them that make them hazardous. Magnesium borings capable of independent combustion. We talked about the hazard of magnesium, right? Ignitable. Beryllium borings capable of producing adverse health effects. Beryllium, if it burns, gives off a very toxic gas. So that was the hazard on that. Any metal contaminated with hazardous waste. So we're not talking about the metal, we're talking about hazardous waste on metal. Any metal with free-flowing oil that is a hazardous waste. What determines in California that oil is going to be a hazardous waste? Does it meet any of the 4 categories that we talked about? Is it ignitable? Is it corrosive? Is it reactive? Is it toxic? The answer to that is no, 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 no. Doesn't meet any of the criteria for being hazardous waste. Oil in California is hazardous waste by definition. It's defined, the state wanted to regulate it as hazardous waste. If you have scrap metal that has free-flowing oil on it, it's got a hazard with it, and it is not scrap metal anymore. Can you separate it from the oil and then recycle the scrap metal under the exclusion? The answer to that is yes. And so if I go out to an industry and they're machining metal and they're using oil as a lubricant, typically they will have some separation area where they let the oil drain off, the oil goes back into the process, and then the metal scraps go into a scrap metal bin. So they do some process to separate those. You're not allowed to have any free liquids go to a scrap metal facility. They're not allowed to take free liquids. So it has to, it can have a thin coating of oil on it, but not enough to generate any free-flowing oil. And then the bottom it says sludges, fine powders, semi-liquids, and liquid solutions that are hazardous waste. So you can't have a liquid metal solution and say it's scrap metal. Fine powders, less than 100 microns. 100 microns is like a fine beach sand. And then a sludge is the byproduct of an air treatment or water treatment system. It's not a gooey, gunky stuff. It has to come from one of those 2 processes, an air treatment or water treatment system. So basically the solids or the liquids that come off of those systems. Those are not scrap metal. All right, let's take a look at one of my favorite metals, waspaloy. It's really, really cool stuff. Waspaloy is used in very salty environments. It will not rust under any circumstances. And then it has very resilient strength even at high temperature, like over 1,000 degrees. It is almost stronger than it is at room temperature. But let's take a look at what metals are in waspaloy. It's got 58% nickel, 13.5% cobalt, 19% chrome. How much chrome is 19%? How many parts per million is that? 190,000 parts per million. The level for chrome per the feds is 5 milligrams per liter. They almost translate back and forth. So it just gives you an idea of how much regulated metal is in this alloy. If I bought this and I'm working with this, did they give me a material safety data sheet saying warning, very toxic material? I never got that. Is it understandable that a business working with this material would not understand the hazards with it? Quite possible, quite possible. All right, so that's my extreme example of an alloy. Processes that generate metal fines. These are areas, if you generate a particle that's less than 100 microns, you are creating something that is not scrap metal. It is excluded for being scrap metal. Then it has to go through the process on waste determination to see what it is. Even if we're going to do recycling on it, we have to know what it is before we can recycle it. If I'm going to use any of the recycling exemptions, I have to know if it's a Rcra waste or a California waste. I got a question.
In your experience, is the common brake shop dust less than 100 microns?
I heard it. The question was on brake dust. In the old days, the brake dust had a lot of asbestos in it, and it would fail for asbestos. They've taken asbestos out of brake pads, no longer has that. Usually the metals that it has are not the metals that we're concerned with. I haven't seen any recent brake dust, and if you go to EPA's or DTSC's website, I think they've got something on brake dust, because I think there was a study that was done. And I don't think they are any longer typically hazardous, but it doesn't mean all situations, you know, it's just like they can talk about what modern brake pads are made of, but if you're working on an old car and it's got old pads, then it's not going to translate to that. It's almost like the paint rule. Typically paints that are manufactured now are not hazardous. So if they're not hazardous, they're not hazardous waste. But that doesn't mean all paints are not hazardous waste, because you could have an old paint that has materials in it that would be regulated. All right, so things that can produce particles less than 100 microns, sandblasting, shot blast, very common at facilities used for cleaning up parts. They will just sandblast them. Honing, that is grinding out the center of a metal part. So they use a stone to actually grind. You're going to create a metal powder with that. EDM metal cutting, that's electric cutting of metal. They use a brass wire. That brass has copper in it. So even if they're cutting something that's not regulated, the wire is going to regulate it because it has copper in it. Grinding, polishing, deburring, and dust collection systems. That would be a sludge. Any questions on those? These are pretty common things as an inspector you see at facilities, right? So what are you going to ask the facility? Show me your waste determination on whatever this stuff is. If they're just throwing it to the trash, what's in it? Procedures for waste determination of solids with metals. This is the most time-efficient, economical way to make a waste determination for materials that contain metals. Looking only at the metal portion, I'm not looking at any other portion. always run a TTLC first. They typically, for metals, just called the CAM17, California Acute Metals. Why do we want to do that? Because it is going to tell us the total concentration of contaminants in that sample. If I can take that total number, divide it by 20, which is the dilution ratio that you have on the federal level, and the number I come up with is less than the number on the table for Rcra characteristic of toxicity, then it is impossible for it to fail even if it was to dissolve 100%. Does that make sense? That was a long-winded sentence. I sounded like an attorney. Straightforward, right? If the total in the sample divided by 20 is less than what it is on the table, it's impossible for it to fail. Do I need to run a T-clip on that? If it's less than what's on the table, I do not need to run a T-clip. On waste determination, what are the two methods that a generator has to make a waste determination? Generator knowledge, right? That's one of them. If they have a test and their knowledge is that of their material, it's impossible for it to fail, they don't have to run that test. What do you think is cheaper to run? A little test that they just take a sample and run it without any preparation, or the one that they have to grind it up and put it in a tumbler for 18 hours with an acid? Which one is more time consuming, more time intensive for the lab person? The TTLC is easy to run, doesn't take long. So it gives you valuable information on both federal and state. Another question. Yes, she's asking, can I repeat the dividing by 20? So if we were looking at the T-clip, that test tells you they take the sample, 1 part sample, and 20 parts acid, mix it together. If it dissolves 100%, then that concentration is going to be diluted by that factor of 20 because of all the acid. Because remember, they're testing the liquid portion. So if you add 20 parts to 1 part, you're diluting it 20 to 1. If I start with 100, then the highest concentration I can end up with is 5. If I take 100 and I divide it by 20, it equals 5. If the threshold is 10, I can't get 10 when the maximum concentration can be 5, right? Does that make sense? It's complicated math. You guys aren't nodding. Do we have lunch coma going on, a food coma? All right, we'll take a look at an example too. So if the test results come back and they're greater than the TTLC, the total threshold limit concentration, if they're greater than, you already know it's a hazardous waste, right? It's at least a California hazardous waste. Now you just have to determine if it's a Rcra waste or not. And there is a hierarchy on this. You have to determine if your waste is a Rcra hazardous waste. If it's not a Rcra waste, then you have to determine if it's a California waste. See if the results are 20 times greater than the value in Table 1. So see, I'm giving you, if you print this out, you don't have to remember this, you just have to go back and read it. Even if the units don't match up, because they're relatively the same. Parts per million and milligrams per liter are relative, not exact. If it is greater than after dividing by 20, then you still have to run the federal test. because it's still possible. Does that mean it's going to fail? Depends on the material. Some materials are very soluble in acetic acid. Others are not very soluble at all. Chromium is not very soluble in acetic acid. You have to have boatloads of chromium before it's going to fail the federal test. Lead, on the other hand, does not need to be in real high concentration. Again, it matters on particle size, the substrate, and everything. But lead is much more soluble than chromium is. They have the same levels. They're both 5 milliliters, or milliliters per liter. So sometimes they could fail, sometimes they not. But the only way you can, if it's greater than the number after dividing by 20, you have to run the test to make the determination, because it's possible that it's going to fail. It doesn't mean that it will fail, but you do have to show that it did not fail the federal test. Any questions on that? One question. Yeah, my favorite. Okay, so he's asking my waspaloy had many metals in it. They are bound together depending on the strength of the alloy. Some are bound more than the others, but it is going to help restrict the ability for it to dissolve if there is bound. You know, if you have metal fillings in your mouth, that's silver, but what did they add to the silver to make it pliable to put it in your mouth? Mercury. So you have mercury in your mouth. That sounds pretty bad, right? But it doesn't leach out because it's bound up in the silver. So it does affect that. And that's why the total concentration doesn't look at that alloy strength, but the leaching procedure will. So all the total test is telling you whether it's possible. It's hard to look at it unless you run it over and over, and after a while you get to know if it's at this concentration, it's going to fail. If it's below this concentration, it's going to pass. But you won't know that unless you run a lot of samples. Yes?
So what if you run a TTLC on that waspaloy? It would fail on the TTLC. So what if a person would take this waspaloy into a little piece and throw it in the trash?
So he's asking the waspaloy sample, and this is a great question. He's asking if I have that waspaloy piece and I decide that I don't want to recycle it as scrap metal, I want to throw it to the trash. You can get in trouble for that, because the exclusion for scrap metal is only if you recycle it. Once you put it to the trash, you lose the exclusion. Can an agency sample the trash? Can they run a test on it? Can they find out that you threw away something that failed the federal test or the state test? And remember, when you put something in the trash, you are relinquishing your ownership. So if I'm doing an inspection and I see something in the trash, I don't have to ask the generator permission to sample that material. Technically, that trash can is not their property anymore. It's the trash company's property. So you don't even need to ask permission to sample this stuff. And if you do inspections and you don't look in the trash, you're not doing a good job on inspection. Should always look in the trash. I've found crazy things in the trash over the years. So that's like inspection number 1 rule. Always look at the back corners and always look in the trash. All right. So I think we beat this horse pretty bad. But now we're going to look if the results are less than the TTLC, so it's not automatically a hazardous waste. See if they are greater than 10 times the STLC. You've already looked at the T-clip. but you have to see if they're greater than 10 times, because remember in the state, you dilute it 10 to 1. So it's different than the feds. Feds were 20 to 1, now the state's 10 to 1. Is it easier just on this fact to fail the test? Yes, because it's got half the dilution that the federal test does. And then you have to look at the numbers in tables 2 and table 3. If it's greater than 10 times, you have to run an STLC. Remember, this is below the TTLC, so it's not automatically a California regulated waste. Now you're trying to determine if it's going to meet the landfill conditions in California. If it fails, it's going to be a hazardous waste. If the results of the STLC are below the numbers listed in table 2, that's where the metals are, then the waste is not a hazardous waste for toxicity per CCR 66261. I think that should be 24, not 23, A1 and 2. However, in California, we still have 6 criteria to go. An example, if I took a sample of solid waste that had lead in it, and it was 100 milligrams per kilogram of lead. In the state and the federal, they're equal, right? 50% leaches. You have a 21 dilution. You got your 50 milligrams per liter divided by 20. The results are 2.5 milligrams per liter. Over here, same results on the leaches, but it's a 10 to 1 dilution divided, and we're at 5 milligrams per liter, and it's a non-Rcra hazardous waste. So under the federal, just because of the dilution, and this isn't really accurate because remember, California uses a more robust acid, and they have a longer leaching period. So you're probably going to get better than 50% leaches on this example. But if I just, all things equal, one it fails, one it passes. So that's a key thing to understand out of this testing process dealing with metals. All right. So now we get into the exercise. So what I have is I have some questions. I have 3 lab results, and I got tables 1 and table 2, which are the federal and the state metals. The easiest way is to take this and break it apart, separate the questions from the rest of the material, and then we got plenty of time, maybe like 20, 25 minutes to go through it, and then we'll talk about the results. So it's all basically what we've been talking about. You guys are going to put it to the test. I feel like I'm at a fireside chat. I just need the little fire in the background. All right. So our first example was done by West Coast Analytical. We had some high results, didn't we? All right. So just looking at the analysis, how long did it take to determine that it was a hazardous waste? I mean, it should have been pretty easy with those kind of numbers. So we're looking at regulated materials. Copper was 420,000. There's not a miserror on the number of zeros. 420,000 milligrams per kilogram. So it is 42% copper. I mean, if people found ore that was that rich, they would be quite happy. And how about the lead? 18,100 milligrams per kilogram. That's pretty high too, right? All right, so in looking at that, and we look at the tables, it's over the TTLC, right? Because remember, regardless of the concentration, we have not run a federal test on this. We're only looking at a state totals test. So in looking at that, is the material a state regulated waste? Okay. Do I need to run a TCLP on this material? Is it possible if I took that lead number and I divide it by 20, do I get a number greater than 5? It's not tough math, is it? So the answer is yes, I need to. So we look, what were the metals that it could fail for? Remember, zinc is not a federal metal, so you wouldn't run you already know it's a state waste, so you don't have to run an STLC. That'd be a waste of money. Chromium and lead. All right. I'm trying to remember for D010 on table 1, selenium. Selenium is 1 milligram per liter. And what's our concentration of selenium? It's 50. So if I take 50 and divide it by 20, is my number greater than 1? So you should include selenium in that answer. So the ones that it can fail for were the cadmium, lead, and selenium. I'm on a question or example number 1. We're still on 1. Question number 2, do I need to run a T-clip? And the answer is yes. And so we were talking about what materials you would need to run it for. If the sample did not fail for Rcra, do you need to run an STLC? Why not? It's already a state waste on the, you don't need to beat a dead horse. The horse is dead, you don't shoot it, it's already dead. It's already a state waste based on the totals test. If it doesn't fail the federal test, you're done. No extra tests. What metals is the waste hazardous for in California? These are California only ones that it failed on the TTLC. And I have copper, lead, and zinc. Zinc's kind of tough because it's way down at the bottom, but that was 247,000. That's way over the totals test. So it failed the TTLC for those metals. Chromium, good question. It was 510, and there's 2 different numbers, and we don't know what level. If we were to pick Chrome 6, it is 500, and it's greater than 500. If it's Chrome 3, it's 2,500, and it's less than that. So unless we have more information, we don't know on the chrome. Typically things in alloys are Chrome 3. Hexavalent chrome is like decorative chrome. It's plated on chrome. Not in an alloy. Usually Chrome 3 that isn't an alloy. So if it's a stainless steel material, that chrome is Chrome 3 in there. In example number 2, get rid of 1, is the sample a hazardous waste? I have yes also. Do we need to run a TLCP, a T-clip, threshold limit concentration procedure on this? Okay, and what could it fail for? I hear lead. Anything else? Chrome? Nickel is not a federally regulated metal. So that's why you have to know which ones are Rcra, which ones are state. So you don't need to run a T-clip for nickel, because look on table 1 and tell me where you see nickel. It's not on table 1. Table 1 is your federal table. Table 2 is your state table. So if it's not on the federal table, you don't have to run a federal test for it. Which metal does the sample fail the TTLC for? So nickel. All right. So we know that it's a hazardous waste. We've got to determine on this one if it is a federally regulated waste. We don't know that. Is it possible for it to fail? Yes, it is. So we have to run that additional test. Let's go on to example number 3. Do any metals need to be analyzed for a Rcra waste determination? I'm hearing yes, and I agree with that. What metals do we need to run? I hear chrome and lead. Okay. So let's take a look at it. And chrome is 220. If I divide that by 20, I get a number greater than 5. So yes. And lead is 330. And the threshold again on that is 5. If I divide that by 20, I get a number greater than 5. I will tell you from experience, the likelihood of it failing for lead is higher than the likelihood of it failing for chromium, just due on the solubilities of the metals. Does it fail any of the TTLC limits? Which ones? I had no. And it was based on it being trivalent chrome and not hexavalent chrome. Does the sample require an STLC to be run if it was to pass the federal? So let's say it did not fail the federal test. Do I need to run an STLC? And the answer to that is yes. And what would we run that for? I have chrome, cobalt, copper, lead, and nickel. And I'm hearing arsenic. I think it's 5. If I take 5 and
85 is the result.
85? So 85 divided by 10 is greater than 5, so I would agree with you. Arsenic should be included on that. Because it's 10, it has to be 10 times greater than the limit. The STLC limit for arsenic is 5 milligrams per liter. If it's 85, I divide that by 10, I get 8.5. That's greater than 5, so it would need to be run for that as well. All right. Yes. Typically, the lab's going to run it for all of them, so you'll get the results back on all of them to see how it is. There's not really much savings in saying which ones to run or not run. Let me go back to my podium, go back to being a speaker. Fireside chat is over with. All right, I got a question.
This gets to, I think what we did in example number 2. Under the Rcra toxicity, you have to test and assign a waste code to every toxin. So if I've got lead that fails T-clip, I can't stop there. I got to check for chrome and barium and everything else. But if I'm seeing this right, you don't have to do that in California. So say like I've got a sample that passes T-clip.
Now, let me stop you. So his question is, if I'm doing a Rcra, I have to determine all my Rcra waste codes. So if it's a D005, D006, D007, I have to list all of those waste codes. California does not have a similar thing. If you do a waste determination in California, you're going to come up with one waste code. You pick the waste code. And a long time ago, California was working on a hierarchy of waste codes so that it would match the federal program. And it just lost traction. The person that was pushing it through retired, and that was the end of it. So we do not have waste codes in California that are similar to what the feds have. The waste codes in California is you pick the one that best fits, and that's it. You get the one. Under the federal program, you are supposed to list all of the waste codes. So if you had a waste that's an F-listed waste, and it also would have D characteristics, you would list those D characteristics as well. You list all the waste codes that apply to it. Okay, that's a good question. Another question? So she's asking, you know, is somebody going to come back and say you didn't go far enough? Under the California criteria, if as long as it's not a federally regulated waste, if you determine it's a non-Rcra waste, you don't have to list all of the characteristics that made it a non-hazardous waste. There are two categories of waste in California: non-Rcra hazardous waste liquid, non-Rcra hazardous waste solid. I'm sure there could be non-Rcra hazardous waste gas, but they're all basically those two things. You do get waste codes that go with them. You only list one waste code, and you're supposed to pick the one that best applies. There's no right or wrong. So you can't go back to somebody and say you used the improper waste code on this. I got a question all the way in the back. So he's asking if a lab comes, how do they know what all to run? Typically the labs are going to start in one area, and they're going to give you the results, and then you would tell the lab what to do for the next step. What you guys looked at were TTLC tests. So remember I talked about always run a totals test first. The lab will give you the results back. And then from that, you're making a waste determination, not so much a waste analysis. So from that information, you're going to determine what needs to be run next. So the lab doesn't really know. The generator is responsible for knowing. So you kind of have to tell the lab what you want done. You could tell them that I want to do a waste determination on this, and they might be competent enough to do that, but who has the responsibility for making the waste determination? Is it the lab or is it the generator? Okay, so if it's the generator, it's your responsibility to know how to do this. And that's, if you're a generator, that's why you're in this class, so that you have a better understanding of this process. And that was one of the main reasons I wanted to teach this class, is so that you would understand the toxicity determination. Okay, you guys ready to move on? All right, we're going to get out of this, and we're going to talk about the other categories. So we have lethal dose ingestion. Now remember, the feds don't really have a characteristic for toxicity characteristic. It's merely a list, right? It's not a characteristic. It's a list. 40 materials on a list. That's a list. How is it different than a listed waste? I don't know. It's not a characteristic. State does have characteristic. This is a characteristic. If it has a lethal dose that is less than 2,500 milligrams per kilogram, so that's, this kilograms is body weight. If it has a lethal dose that's less than this amount, it is toxic in California. That's a characteristic. The tricky thing when you're doing these is as the number gets bigger, it gets less toxic. It seems counterintuitive to everything we've been doing, right? Big numbers are bad, small numbers are good. Now we're doing the reverse. Big numbers good. If it has an LD50 of 10,000 milligrams per kilogram, it's not toxic because that number is greater than. See, it says less than. So when you get that lab result back and it says 100,000 or something like that, don't pass out. Oh my God, no, it's not toxic. It's the opposite direction. Take a look at some materials on LD50. Where can I get LD50 information? MSDSs are good. Another great place is Google. Type in the material LD50. Bam, just like that. So nicotine. Is nicotine less than 2,500 milligrams per kilogram? Okay. What about caffeine? If I made some bad caffeine tablets, it was Steve's Super Wake-Up Pill, and it was a flop. Nobody liked it. I couldn't sell them, so I had to throw them away. I would have to make a waste determination to see what the concentration of caffeine is in my crappy stay-awake pills. These are common materials, right? I didn't pick like weird chemicals. Do we ever run into nicotine? Yes. Do we ever run into caffeine? Yeah, we got jugs of it all throughout the conference, trying to keep me awake, keep you guys awake through my class. Table salt. Look how close table salt is to being a toxic material. Pretty close. Anybody ever put salt on their food? So toxicity, it's all about dose, right? Concentration is what makes it. Grain alcohol, even vitamin C has an LD50. References for toxicity, these are great references, but Google. It's a modern age, everything's right there on your phone. I could probably give you a chemical, and within 30 seconds you could give me an LD50. Lethal dose dermal. So we know that our skin is not necessarily a barrier to all materials. So if I have a chemical on my skin, it could penetrate in, and if it causes death, a lethal dose of less than 4,300 milligrams per kilogram, it's a toxic material by the state. That would make it a hazardous waste for toxicity. Do you think anybody ever does a dermal LD50 test? Let me ask you guys, how do we do these tests? Well, it's usually rats, but some cases it's rabbits. But it's usually rats. And it's usually 10 rats per test. Because you need a population to determine what 50%. You can't use one rat and one leg goes bad, so it's 25% lethal. If both legs go bad, it's 50%. If 3 legs go bad, no. They need a population, so it's usually 10, and they have to have a control, right? How many specimens do you need for a control? The same amount as you had for your test population. Can you use those animals again after the test? So one test, a minimum, you've got to euthanize 20 animals. So it's pretty barbaric to run these tests. But there, fortunately, is a lot of data out there, and you can get this information I've never seen anybody run a dermal test for toxicity on their hazardous waste. Yet, it's in the regulations. So this is what it is. But you can use information to find this out. Lethal concentration inhalation. So this is wrong. It shouldn't say LD50, it should say LC50. Less than 10,000 parts per million of gas or vapors. I know I corrected it. I must have got a bad copy of this. And then acute aquatic toxicity. Less than 500 milligrams per liter within 96 hours. And this is pretty common, right? The fish bioassay. But to me, it's how much sense does it make to determine if it's going to kill fish and make it a hazardous waste if the material is not going to a landfill? What if I have a liquid and I send it to a wastewater treatment plant? Do I care whether it kills fish or not? Is it really important to make sure that it goes to a facility that has a Rcra or a state permit for treatment of hazardous waste? I'll give you an example. Shampoo will kill fish. So if you have waste shampoo, then under California, it would be a non-Rcra hazardous waste. I don't see anywhere where facilities are managing their shampoo as non-Rcra hazardous waste, but yet it will fail the fish bioassay. Now, if you were discharging to a river or the ocean or something like that, I can see the applicability of this test, but it's in the regulations. So the test is 20 fish are tested, 10 per tank, so it takes at least 2 tanks, plus you got to control population. Checked every 24 hours. Test tanks are 10 liters. Fish are not fed during the test. Equal number of fish for a control, so you got to have more tanks. 3 types of fish can be used for the test. It's pretty arduous to do the test, right? It's not that simple of a quick little test to do. So you can use rainbow trout, but if anybody knows anything about trout, if you look at them wrong, they're going to die. So nobody ever uses trout. Another one is a golden shiner. Don't confuse them with golden shriner. That's something totally different. Although they may be good test subjects, but they're not fish. And fathead minnow, see these poor guys, don't they look cute? This is what everybody uses. Yeah. Do you think they want to go in the tank with the chemicals? This is what PETA wants. The cherry ones are delicious too. I don't like the yellow ones, but I really like the cherry ones. All right, on to criteria 7. Weight-listed concentration for carcinogens. And this came from OSHA documentation on known carcinogens. How many people know any of these 16 materials? Has anybody ever looked at any of these 16 materials? Yeah, once in a while. Okay. The common ones would be vinyl chloride. What do we use vinyl chloride to make? Polyvinyl chloride, PVC. And acrylonitrile, that's used making plastics as well. The polymers of this stuff are very non-hazardous. How come you guys are leaving? Are we out of time? I don't know what happened. All right. We're getting close. Number 8, been shown to pose a hazard to the environment. This is the actual regulations. Been shown through experience or testing to pose a hazard due to carcinogenity, acute toxicity, chronic toxicity, or bioaccumulative properties or persistence to the environment. What? So DTSC, to create regulations, California Health and Safety Code states that the department must determine by regulation that the waste classification is likely to have broad application beyond the producer. Basically eliminates this. The state has to determine what would be in this category. The state has never determined anything to be in this category. It's in regulation, but in the law, they basically removed it. And then just a recap. And then just quickly, acutely hazardous waste versus extremely hazardous waste. Rcra, acutely hazardous waste, P-listed. You guys should know what these are. If you're a generator or an inspector, you need to take a look at this list. Every once in a while, something will catch you. Is everybody aware that sodium azide is a P-listed waste? So if you have off-spec, out-of-date, bag deployment cartridges, and you want to get rid of them, that's a P-listed waste. Remember, 1 kilogram threshold in any given month for large quantity generator status can require a biennial report if you're over that. Containers must be triple rinsed before they're disposed of. Big pharmaceutical issue. Must be from an unused single ingredient material, and watch lab cleanouts and pharmaceuticals. The one that we never think about is California extremely hazardous waste. Tells the criteria. Basically what it did is it just lowered the thresholds. So if it meets these toxicity thresholds, it is extremely hazardous waste. So you can get a large quantity generator status if you generate 1 kilogram or more in a given month. It can affect SB 14 pollution prevention plans, but doesn't require triple rinsing. Pop quiz. What is the percent of solids a liquid can have and not have to run a T-clip? What was the threshold? And so I got it wrong on the thing? Because I thought it was, I have on there 0.5. You might have to check that one. How much longer is the state's leaching time than the federal T-clip? 30 hours. A company wants to use scrap metal exclusion to recycle copper particles collected in a dust collection system. The particles are greater than 100 microns. Can they legally do this? The answer is no, because it's a sludge. Oh, caught by a sludge. How many days does the aquatic toxicity test take? So don't call them up and say, I need this in 2 days. Company generates waste sandblast grit from cleaning stainless steel parts. The waste is a Rcra hazardous waste. The company wants to send the material to an asphalt plant to make into asphalt. The waste can be used without any treatment to the waste prior to use. Can the company do this? No, because that's sham recycling. Whatever is making a Rcra waste is not part of asphalt. All right, so here I am teaching SW846 sampling, fascinating stuff. This is how you figure out sampling for non-homogeneous waste streams. And my favorite slide, heavy metal in the marine environment. All right, thank you very much. Please give me feedback on your evaluations. It's important to us. Thank you very much for sticking it out. Sorry I went long.